Hello. Last week, a friend of mine asked me to design a small PWM module for him, with an adjustable frequency from 0 to 100 kilohertz. I've finished the design and have also shared it with you. My friend intends to use this module to drive a 21-volt battery-powered ultrasonic cleaner. However, you can also use this module to build your own small inverters. With an adjustable frequency range of 50 to 100 kilohertz, the module can be used to drive the MOSFETs of an inverter with either a conventional iron core transformer or a high-frequency ferrite transformer, depending on your application. The module also features feedback control and low battery protection. I would like to express my sincere thanks to JLCPCB for generously sponsoring the PCBs for my projects. Many of my projects probably would not have been possible without their support. Today, I'll show you the simplest way to order PCBs from JLCPCB. First, you need to create an account. You can sign up quickly using the link I've provided below this video. Next, upload the Gerber files I've provided. Once the Gerber files have been uploaded successfully, you can do a final check of your PCB using the built-in 3D viewer. This tool is extremely useful. It allows you to easily check for potential design errors and preview what your PCB will look like once it has been manufactured. Next, you can choose the PCB color, PCB material, and many other manufacturing options according to your requirements. Once everything is configured, simply add the order to your cart and proceed to checkout. Don't forget to apply any available discount codes to help reduce the overall cost of your PCBs. JLCPCB is currently offering great deals for new users, so go ahead and sign up now. This is a small project with very few external components. The main controller IC is the SG3525 with an external S8550 S8050 totem-pole driver stage capable of delivering up to 1A of peak gate drive current. It can drive up to 20 MOSFETs per side at 50 Hz or 10 MOSFETs per side at 30 kHz without any issues. All components are through-hole components, making the circuit easy to assemble and repair. I think the entire build should take only about 15 minutes. Even for someone with little electronics experience. The completed board is quite compact, about the width of 2 fingers, so you can easily integrate it into your own projects. Simply connect the 2 power supply pins and the 2 control signal pins to the MOSFETs, and the circuit is ready to operate. If you want to regulate and stabilize the output voltage, simply connect the feedback pin. Otherwise, you can leave it unconnected. I will check the output waveform with an oscilloscope. As you can see, the output waveform is very clean, which helps minimize MOSFET switching losses and reduces heat generation. When the supply voltage drops below 10 volts, the circuit will shut down the output. The low battery cutoff voltage is set by a Zener diode. Use a 9.1 volt Zener diode if you want the circuit to shut down at 10 volts. Here I have a sample circuit using 2 MOSFETs and a high-frequency transformer. With just 2 MOSFETs, we can easily achieve an output power of around 300 watts. If the power is kept below 150 watts, a heatsink may not even be necessary. Please note that when using a high-frequency transformer, you should increase the switching frequency to around 15 kHz to 40 kHz. With an iron core transformer, the wiring is exactly the same as with a high-frequency transformer. The only difference is the operating frequency. Set the frequency to around 50 to 60 Hz. If you don't have an oscilloscope, you can connect the transformer output to an electric fan and adjust the frequency until the fan runs with the minimum amount of noise. You can download the project from the link in the video description. If you have any requests or suggestions, feel free to leave a comment below, and I'll do my best to make them happen.